All right, good morning, everybody. Thanks again to everyone for being here on time for our early class. We're going to continue today with the appendicular skeleton. So this is where we left off on Monday. So a little bit of a brain transition going from, we've been bouncing around a little bit between lecture and lab, between the skeletal system in lecture and histology in lab yesterday. Next week, we will get into your lab. Next week will be on bones, and a lot of the ideas that we've been talking about in lecture, and we will continue to talk about, you'll be able to see firsthand. So know that in lecture, I'm going to be talking about things, showing some diagrams. In lab next week, you're going to have examples of all of these to pick up in your hand and to move around and to articulate and all that fun stuff. So our agenda today looks like this. Actually, I have a thank you for the class to start. You'll see what that's about in a second. And then we're going to quickly review a few concepts from lecture and from lab. And then we're going to get into the pectoral girdle. We started off, we talked about the pectoral girdle a tiny bit on Monday. We're going to continue that, then talk about the bones of the upper limb. And if we have time, we'll get into the pelvic girdle and wrap things up. The quiz reminder and a ticket out. So before we get into the agenda, any questions about what's going on in class? All right, so here's my thank you. On the ticket out Monday, I had a required question that asked you to upload a photo, but we didn't get to that activity. And I said, upload cute pictures of animals. And I just want to acknowledge that you all have very cute pets. And it kind of made my day when I was going through and like finding all of these pictures. So thank you for that. I like this yawning cat, I think especially. I don't know whose cat that is, but it's fantastic. Also on your ticket out, there was this question: which of the following is a function of your lumbar vertebrae? Select all that apply. And so here you can see the class results. So just as a little bit of background, when I look at your responses to the tickets out, generally what I do is look at them in this format. For those, it's not really important to me who's getting which questions right or wrong. What's important to me is looking at the class totals and making sure that the class is understanding the concepts. And sometimes it makes me want to, it's good information for me to kind of back up and make sure we're talking about some things. And so there's your responses for this question. Just a couple of you said that the vertebrae surrounds and protects the spinal cord. Most of you said it provides a site of attachment for back muscles. Most of you said it transmits weight to the lower limbs. And a few of you said it directly articulates with the pelvic girdle. So I want to make sure you have the correct information. It's in fact, these two responses were correct for your lumbar vertebrae. Most of you got this one, transmits weight to the lower limb. So all of that weight kind of transmits down your spine to the pelvic girdle. What's important to note, it does not articulate with the pelvic girdle. Your lumbar vertebrae articulate with the sacrum, which articulates with the pelvic girdle. So the lumbar vertebrae do not directly articulate with the lower limbs. Rather, they articulate with the sacrum. And then the first one is probably the one that's a little bit of a trick question. Your cervical and thoracic vertebrae surround and protect the spinal cord, but remember the spinal cord only extends down to about between L1 and L2. It can vary from person to person. So maybe your L1 vertebrae does protect the spinal cord, but in general, the lumbar vertebrae do not protect the spinal cord simply because the spinal cord doesn't extend. And so all of you have probably heard of the medical procedure called a spinal tap, is when they extract cerebrospinal fluid. They do that from between your lumbar vertebrae because your spinal cord doesn't extend that far down. And so when they stick the needle in there to extract some fluid, they're not going to risk hitting and damaging your spinal cord. That's why that spinal tap happens in the lower region of the back, where there is the spinal cord after the spinal cord ends. I'll say it that way. So just want to make sure you've got that concept. We can look at a diagram here. So this is from lecture on Monday. Maybe I covered this on Friday, I don't remember. But the spinal cord extends to about down here. Excuse me. The spinal cord extends to about down here. The sacrum is this bone right here, and this is the bone that articulates with the bones to form the coxal bones to form the pelvic girdle. Of course, all of these vertebrae serve as important attachment sites for muscles of the back. So that's correct for any of the cervical, thoracic, or lumbar vertebrae. So just a bit of review. Want to make sure you've got that. What questions do you have? Okay. One other piece of review I want to talk about, I graded your anatomical terms worksheet from lab. So this is lab material, but it's just easier to present it here in lecture format. I want to make sure that a couple concepts are clear. One is the pleural cavity. This is a little confusing, and I went back in the information the way it was presented, and I want to make sure I'm clear on this. The pleural cavity actually is this space that's between these two membranes that surrounds the lung. So in a very technical sense, the pleural cavity only contains this fluid that's actually really important. We'll talk about this when we get to the respiratory system, but it doesn't actually contain the lungs. Think of like a folded pocket. So the lung is kind of inside the cavity, if that makes sense, but it's not between these two membranes. So technically, the pleural cavity only includes the fluid that surrounds the lung. So a good way to think of that is the pleural cavity surrounds the lungs, but the lungs are not inside that cavity technically. I just want to make sure that's clear. I didn't present it clear in lecture, in lab. When we talk about the respiratory system, we'll get into this in the layers of the membranes that form this pleural cavity. Sound okay? The last bit is the cranial cavity. The cranial cavity, I want to be clear, is this cavity in which the brain sits. In your anatomical terms worksheet, many of you said that the brain cavity, the cranial cavity included the bones of the skull. It does not. The bones of the skull essentially form the cranial cavity in which the brain sits. So just make sure you've got that clear. When I graded those anatomical worksheets, I gave you, if the worksheet was worth 8 points, if you got 2 questions wrong or less, you got full credit. If you got 4 questions wrong, if you got 3 or 4 questions wrong, you lost 1 point, so you got a 7 out of 8. And if you missed more than 4 questions, then you got a 6 out of 8. So if you have any questions about your grade on that or want to see which ones you got wrong, I don't have a good way to give it back, that information back to you, other than just sitting down and looking at your answers, which is probably best anyway. So if you have questions about that, we can look it over in next week's lab, or open hours next week is probably the best place. Make sense? Cranial cavity? Cool. All right, let's talk about your appendicular skeleton. So this is a bit of review. We covered this on Monday. The pectoral girdle includes just 2 bones, your clavicle and your scapula. Of course, 2 bones on either side. You have left and a right clavicle and scapula. And important to note, this is the only point where the pectoral girdle, and therefore your upper limbs, articulate with the axial skeleton, is this sternoclavicular joint. And this is the joint, you put your fingers on your collarbone here and you kind of move your arm in front of you, you can feel that joint. It's actually a very flexible joint right there. Now, the trade-off of the pectoral girdle is essentially increased flexibility for reduced stability. And so we can do all kinds of things with the shoulder. We can move it in all directions. We can rotate it in all different ways, but it's not the most stable joint. And the lack of stability stems from this very shallow cavity where the humerus articulates with the scapula, but also from a potentially fragile fracture point at the clavicle. So you can get a broken collarbone pretty easily as well. And we're going to talk about that and have some images coming up. So we covered that on Monday. Let me just re-emphasize a couple pieces of vocabulary I want to make sure you know from these diagrams. Of course, you need to know the names of the bones, but you should make sure you know the sternoclavicular joint is here between the sternum and the clavicle. The acromioclavicular joint is here. That's on the distal end of the clavicle, where the clavicle articulates with the scapula. And then also make sure you know the term the glenoid cavity. Is this shallow kind of cup or bowl shape feature on the scapula where the humerus articulates. I'm going to show you that in a little more detail coming up. That's mostly what I covered on Monday. So let's move on and talk about your clavicle specifically. The clavicle is a little bit of a tricky bone because it's really hard to tell which side is proximal and distal and which side is superior and inferior. There's some features on the bone that will help you identify if you're given a clavicle, if it's the left or the right clavicle and how it sits. I'm not going to get into that right now in lecture, simply because I think it's much easier to do in lab when you can actually have that bone in your hand. So just know that we will talk about that more in lab next week. As I mentioned, the clavicle articulates with the sternum on its proximal end, and so and specifically articulates with the superior most part of the sternum known as the manubrium. And on the distal end, the acromial end, it articulates with the scapula. And we talked about that. And you can see that the sternal end is kind of flat. You can see this kind of flat end there, whereas the end that where it articulates with the scapula is more rounded there. And that's one of the features that we'll look at in lab. I mentioned that you can break this bone pretty easily. Generally, where it breaks is on the anterior end in the middle third of the bone. So it generally will break. This is the inferior root. It's generally going to break like right in this region here, where it kind of bulges out. And you can feel it. You can run your finger along from your sternum to your shoulder blade. You can feel how it kind of bows outward. That is the place where it's most likely to break. And it kind of looks something like this. The way the bone is curved, that break tends to break the bone kind of outwards. And what happens, since that's the only point where your upper limb articulates with your axial skeleton, when that bone breaks, you essentially lose functionality in your whole shoulder and your limb. Like I don't know if anyone in here has had a fractured collarbone, but you have to keep that whole joint immobile, and essentially it basically ruins your ability to use that arm at all. I see a couple nodding heads that have had broken collarbones. It does generally heal up pretty well, as we've talked about bone can do, but it's important to note that that's the only point, or this is the only way that axial skeleton articulates with the limb. And so if it breaks, you're kind of out of luck. I'll talk a little more detail about the functions of the clavicle. In addition to providing that structural support to the upper limb, there are a number of muscles that attach to it. And I have the names of some of those muscles here. You don't need to worry about the names of those muscles now, but I want to introduce you to those terms because we will cover them in detail later in the semester. So your pectoralis major, which is your pecs, in the anterior of your chest, your trapezius, which is a large muscle on your back. So it serves as attachment point for muscles both in your front and your back, as well as part of the deltoid. The deltoid is the big muscle that goes over your shoulder. It's where you get shots usually because it's a big kind of meaty muscle. And so all three of those muscles have attachment points on the clavicle. Additionally, the clavicle holds the scapula in place. I kind of talked about this. Its functionality is lost if the clavicle is broken, of course. And finally, it serves to transmit compression forces from the upper limbs to the axial skeleton. So compression forces means when you're doing something with your arms, that puts your body weight on those arms. So this can be anything from a push-up to hanging from a tree branch or doing a pull-up or standing on your head, even if you're inverted. In all of those scenarios, that weight is being transmitted via this clavicle from your limbs to your axial skeleton. It's an important little bone. We don't think about. I think we should think about the clavicle more in our daily lives than we do. It's a little bit underrated. I'm going to pause there. I'll walk through a lot of clavicle detail pretty quickly. And I want to just emphasize that you'll have these in hand in lab and be able to take a closer look at these more detailed features of it. I'm not going to talk about it right now. I want you to understand the kind of general structure of it and its general functionality. Go ahead on.
Is there like evolutionary benefit to why it's a curved bone instead of just straight bone?
Is there an evolutionary benefit to why it's a curved bone instead of straight? Yeah, that's a great question. If I had to, I don't know 100%, but I'm going to speculate on this one because I have a pretty good idea. Generally, curved structures are actually stronger than straight structures and can withstand especially more compression forces. So my best guess is that it essentially increases its strength and its ability to sustain that weight. And also, sometimes with bones, it's going to sound a little weird, but it's advantageous if when they break, because of undue stress, they break in a certain way that doesn't damage internal organs or things like that. So again, I'm speculating here, but that this curvature And we mentioned that it tends to break in the same spot, allows it to break in a way that it can kind of heal easily and not risk damaging other tissue. That's a really good question. It is kind of funky shaped. It's like an S, a sideways S, basically. Cool. Well, let's talk about the clavicle's best friend, the scapula. No offense to the manubrium, but you know, these guys, this bone, this bone is definitely the poster child for an irregular shaped bone. If you look at this bone from different perspectives, it looks totally different. And so what I want to show you here is the anterior aspect of your right scapula. So in other words, you're looking at my scapula right now as if I'm facing you and on the right side. So this surface faces anteriorly. You can't see the surface that faces the back. And then this is where the scapula articulates with both the clavicle and the humerus at the shoulder, right? Now, the scapula generally, broadly, is kind of a triangular shape, as you can see here, and it has three borders. The superior, which is this top border, the medial, which is the vertebral border, which is this down here. Remember, if I'm standing here like this edge is kind of running parallel, more or less, to my my vertebrae. And then the lateral border, which is right here, which lateral refers to on the side, there. So we've got this big triangle there. The scapula serves as an important attachment point for muscles of the back and the arm. So specifically muscles that are involved with the rotator cuff have their attachment point here, such as the teres major, teres minor. You've got your rhomboids attached there, which are some back muscles. Again, right now, I don't want you to know that, well, you do know that's great, but you don't need to memorize the names of those muscles. Just want you to be thinking about these bones as attachment points for muscles. Functionally, the scapula has some interesting pieces. So now we're going to look at the scapula from the posterior aspect of the right. So this is as if I'm standing like this, and you're looking at my right shoulder from the back. And so you can feel this, you can see here the spine of your scapula, and you can feel that right here. If someone's giving you like a shoulder massage or something like that, that's where they're kind of getting in there in those muscles right there. And you can feel that spine very, very clearly just by reaching one arm around and grabbing your back there. This feature is in fact called the spine. And there's two other features I want you to know that you can see really well from this angle. One is the coracoid process, and one is the acromion. Remember, the acromion is the site where the clavicle articulates. So that's the acromioclavicular joint. So the clavicle comes and articulates with the acromion kind of right here. The coracoid process, we'll talk about more in a second. That's the site of attachments for some ligaments. So that's what it looks like from the posterior. Oh, look, I have the slides for this. Okay, so the coracoid process, basically, it's kind of, there's ligaments that are bound there that kind of keep the shoulder joint intact, and also is this attachment point for your biceps brachii. So the biceps brachii is your I don't know, your beach muscle in your the anterior aspect of your humerus, the muscle right here, and so that muscle actually attaches to this coracoid process. In addition, the scapular spine extends here and basically continues to the acromion here. Again, remember that's where the scapula articulates with the clavicle. And the other feature that I mentioned briefly before is the glenoid cavity. This is that shallow cavity where the humerus articulates. Now, in this view, you're looking at the right scapula from a posterior view. The glenoid cavity kind of is facing this way, so you can't see it really well from this perspective. I'm going to rotate that and show you glenoid cavity in just a minute. And pause there, make sure you've got that. Got a couple more slides in the scapula, and then we're going to do a little drawing activity. I want to introduce a new vocabulary word for you, and that word is fossa. A fossa is a part of a bone that's essentially a big flat surface, and you'll see some examples of that throughout the semester, but there's three fossae, that's the plural of fossa, on the scapula that I want you to know. There is, if we're looking at the scapula from the posterior view, so again, this is looking at my scapula from this angle. We have the supraspinous fossa, which is this flat area here, and we have the infraspinous fossa, which is the flat area here. Now, an easy way to remember these names is, of course, this is the spine of the scapula, right? Supra means above, so this is the flat area above the spine, supraspinous fossa. Infra means below, so this is the flat area or fossa that's below the spine. So supraspinous and infraspinous. Additionally, if we're looking at the right shoulder from the anterior aspect, so this is like this, we have the subscapular fossa. And so this is the big flat area that kind of lays against, it doesn't articulate with, but essentially follows the curvature of your ribs along your vertebrae, or your ribs articulating with your vertebrae in your back there. So we've got three big flat areas that you should know. And again, we'll talk about this in more detail in lab. And I'm going to show you the scapula from one other angle. And this explains a little bit about why I said it was such a weird shaped bone. So if we look at a right scapula from the lateral aspect, it looks totally different and has this almost like a kind of wrench shaped face. So this is a right scapula from the lateral aspect. So this is looking at my scapula like this. And here you see that it's this long, thin surface, right? And now we can see that glenoid cavity really nicely, because that glenoid cavity kind of points laterally. That's what articulates with your humerus. And you can then see here, if we look at it from this angle, this is the subscapular fossa, will be the flat area that's facing forward. Our infraspinous fossa is in the back from here. Supraspinous fossa is going to be up here. And we have some other features. The coracoid process you can see well from this angle. The acromion you can see really nicely. I mentioned this glenoid cavity there. Yeah, I'll leave that at that. But I just want to make sure that you can identify those features on the scapula from different angles. And it does look wildly different when you look at it from the side like that. Questions? Okay, as promised, we have a drawing activity. I want you to draw a left scapula from the posterior aspect. So I'm actually going to, here, I'll make it a little bit easier. So I'll help you out with that diagram there. So go ahead and essentially recreate that diagram. So this is a left scapula from posterior. So this is as if I'm standing here and you're looking at my shoulder. And then label these 6 features on it. I'll give you a couple minutes to make that drawing and we'll check back in. Do you need more time? Are we good? Another couple seconds here. I see some people still writing. It's great. All right, let's have a look. Your diagram should look something like this. From this angle, we have the supraspinous fossa above the spine, infraspinous fossa here below the spine. Of course, the spine goes across here, coracoid process, chromion, and then kind of laterally here that you can't see very well at all from this angle, but this is where the cavity is. What fossa, what's the other fossa that you can't see from this angle? Subscapular fossa, good, because it's facing back that way towards the back range. Questions on the scapula? All right, let's talk about the upper limb then. So we talked about the pectoral girdle is the bones that form the joint at the shoulder that articulate the axioskeleton with your limbs. So let's talk about your upper limbs. We have 30 bones from each of your two limbs. You have 60 bones of your upper limbs, and we kind of group them for each limb into 3 different groups. So we have the arm, which is known as the brachium, and so that is from your shoulder to your elbow, right? And there we have essentially, we have one bone, it's the humerus. Then we have the forearm or antebrachium, which is from your elbow to your wrist. And there's 2 bones in that region of your arm, the ulna and the radius. And then finally, we have the hand, which includes all of your carpals down here, which are the bones of your wrist, and then your metacarpals here, which are all the bones of your fingers. And we'll talk about those in some detail in just a second here. So that's generally the lay of the land. Notice here that in anatomical terms, when we say the word arm, we only mean this specific part of your limb from your shoulder to your elbow. Generally in everyday vocabulary, we kind of refer to your arm as this whole thing, but specifically in anatomical terms, we call it that. It refers to just that segment. Now, in general, because that's kind of confusing, I'll avoid that and I'll refer to that as your brachium. Sometimes I'll just call it your upper arm to contrast with the forearm. So let's talk about the bones of that brachium first, or I should say bone, singular. We just have one bone, the humerus. It is the longest and strongest bone of the upper limb. It articulates with the scapula at the glenoid cavity and its proximal end up here, and articulates with the radius and the ulna on the distal end at the elbow. I was going to make a joke, but there's nothing funny about the humerus. It's stupid. All right, so let's take a look at the humerus in a little more detail here. And again, we're going to cover this in lab. So, we just want to emphasize that you're going to learn this material at least 3 times. You're going to learn it in lecture today. You're going to learn it when you read your textbook sections on it, and you're going to revisit it in lab. So if it feels like it's going a little fast today, you're not getting everything, that's okay. The way I have class structured is that you're going to revisit these concepts in different ways. And then by the end of that, then you should have a good understanding. So there's a bunch of features on your humerus here. I want to talk about a few of them. The first is the head of the humerus. This is essentially the kind of bulbous end of the bone. You'll see that word head used we have many bones of the body have part of the structure called the head. We have on the head, we have this greater tubercle. This is this kind of flat but rough area here. I can't reach it. That is where your rotator cuff muscles insert. So especially those of you that have played baseball, softball, often hear about pitchers getting rotator cuff injuries. That's there's a set of 4 muscles that basically allow your arm to throw a ball. And they have several of them have their attachment point Notice the vocabulary on this slide in red. Those are probably new vocabulary terms that I want to make sure you get and you understand. So that's why I highlighted them in red. And again, we'll cover all of these in detail on that. Couple other features, we have a groove that kind of runs down the length of the humerus called the radial groove. And basically your radial nerve sits along that groove. So it's basically a spot for your nerve to kind of, it's a little track, I'll call it, for that nerve that runs down there. We also have this part of the bone that kind of sticks out a little bit, almost like a crest kind of. It's called a tuberosity. And that is an attachment point for your deltoid muscles. So I said your deltoid muscles attach on your scapula, and that's where their their origin is. Their insertion is on kind of midway down on your humerus, and that allows you, when those muscles contract, to move your arm up like this. We also have fossa. So we talked about fossas of the scapula, those flat areas. We also have fossa in this area of humerus as well. It's kind of a little flat area. And then we have two what's called condyles, a medial epicondyle and a lateral. So let me back up for 1 second and make clear that this is a posterior view of right humerus. And so this is me standing like this in the anatomical position. You can see where that head articulates with my scapula. And then this is going to be the back of your humerus going down here. And so the lateral epicondyle, lateral meaning on the outside, is this part here, and the medial epicondyle is this part here. And those serves as attachment points for muscles that help flex your wrist and your digits. The last thing I want you to know, and I actually should have this highlighted in red, is this part called the trochlea, which kind of almost like cylindrical piece. That forms the joint with your ulna that forms your elbow joint. And I'll show you that from the ulna perspective. So that's a posterior view of the humerus. And I want to back up the radial groove. This is no, I'll leave it there. That's the nerve that's going to run down kind of the back of your humerus. We look at it from the anterior view. We can see some of the same features. You can still see the head of the humerus, the greater tubercle. Here we can see another tubercle called the lesser tubercle. It's basically the little cousin of the greater tubercle. Again, attachment points for some of those shoulder muscles. We have this kind of groove here where a tendon attaching your biceps muscles runs called the intertubercular sulcus. I'm going to focus on the features in red here. If we look at the humerus, this is from an anterior view. So this is like this. We have another flat area here called coronoid fossa. That's just proximal to the trochlea here. And we have the other feature is the capitulum, which is this kind of round area here, just lateral to the trochlea. And this is where the radius articulates. So I'm going to talk about that elbow joint in a little more detail in a second. I just want to show you those features on the humerus. Let me pause there. I'll leave it there before I talk about the bones of the forearm. What questions do you have? Okay, let's work through the bones of the forearm, or the antebrachium. This part of the limb is formed by the ulnus in the ulna in the radius. And so this view right here is a right arm looking from the, that's it, looking from the anterior view. So this is me standing like this in the anatomical position. Notice in the anatomical position, the radius is lateral and the ulna is medial. So the ulna is running down here, close to my body. The radius is over here. Notice in the anatomical position, these bones are parallel, right? They don't cross over, and that's going to change when we rotate our arm, and I'll show you what that looks like in a second. Now, these two bones articulate on their proximal end. They articulate with the humerus, which is up there, and on the distal end, they articulate with the carpals, or the bones of the wrist. what's pretty cool about these two bones as well, I think it's cool, is that they actually have two joints where they articulate. And these are called the radio-ulnar joints. And we have a proximal radio-ulnar joint and a distal radio-ulnar joint. So if we want to talk about the joint between the ulna and the radius, we need to specify, because there's actually two places where these two bones articulate with each other. There's not too many other examples of that in the body. The tibia and the fibula is the only other one that I can think of off the top of my head. So we have these two bones running more or less parallel. They have articulations at the proximal and distal end. And between them, we have something called the interosseous membrane. So this is composed of dense, regular connective tissue. And it's this membrane between these bones that really binds them together and holds those two bones very tightly in that position. And I mentioned this earlier, in the anatomical position, the radius is lateral. So this is our radius over here, and the ulna is medial. I'm going to talk a little bit more about each of these bones, and then we're going to mix it up a bit. So the ulna, as I mentioned, forms the elbow joint with the humerus, and it has this almost like C-shaped or like clamp-shaped feature on its proximal end, and that basically forms a hinge with that trochlea of the humerus, and I'll show you that on my next slide. The distal end of the ulna is actually interesting. It doesn't articulate directly with the carpals. There's actually some fibrocartilage in there that separates it. So it doesn't, the ulna, what I want you to take away from this is the ulna is important for articulation at the elbow and not the wrist. So we have these two bones running parallel. The ulna articulates with the humerus at the elbow. And I'll talk about the radius in just a second, but I want to show you a couple features. A couple features you should know are these notches, the radial notch, the trochlear notch, and the coronoid process. These are all places where the ulna articulates with the bones of the humerus or the radius. And then down here, we have something called the styloid process. I'll talk more about in a minute on the distal end. And that's this little kind of bit of bone that kind of sticks out there at your wrist. And that actually is prone to breakage as well. You can see here a close-up of the elbow joint. So we have the distal end of your humerus. We have this trochlea, this like almost like cylindrical-like feature on the bone. And then we have the ulna articulating with that here. And that ulna, as I mentioned, has this kind of C-shaped or clamp-shaped feature on its proximal end. And this is called the olecranon. And so that olecranon is this cup that basically fits right around that joint. And that allows, that provides the structure for this joint at your elbow that is really strong at moving in this direction, but at the same time can't move it all side to side. Your elbow has very limited flexibility if you try to move it laterally at all, but it has great mobility in this one direction. So these structures of the bones provide the shape of that articulation and limit where that joint can move. And you contrast that with something like the knee. The knee in general is also very good at flexing this kind of anterior to superior way. But you actually do have some flexibility side to side in your knee, a little bit of lateral movement, not as much. And if you do it too much, you can injure your knee. But your elbow, I mean, try to move your elbow side to side. Don't put too much force on it. And it basically can't move at all. And that's because you have these bony structures that provide that really strong joint, the limit movement in one direction, but provide movement in the other direction. All right, let's talk about the radius and then wrap it up for today. The radius has two articulations on its proximal end. So it articulates with the humerus at the capitulum here, right? And here we have the head of the radius. I mentioned a lot of bones have a head structure. And then at what's called the And then it has the proximal articulation with the ulna there. And what do I want to say about that? I just want to add that it articulates with the ulna at this radial notch, this little kind of indentation. So head of the radius articulating with the capitulum of the humerus and at the radial notch of the ulna. And what's cool is that joint is actually the head of the radius is actually this almost like it's like this circular head, and that allows that joint to rotate. And so what we have here is this hinge joint with the ulna and the radius that provides this movement. But then we have this rotating joint here at the proximal end of the proximal radial ulnar joint. And so what that allows is your hand to move, your arm to rotate this way. So even as your elbow can't move laterally, you can rotate your arm at the elbow thanks to this head of the radius rotating within that radial notch of the ulna. And if we look at that, I want to show you actually an illustration of that. Well, let me show you a little bit more about the radius, and I'll show you a video of that kind of articulation. So this is looking at the ulna and the radius from the posterior. So this would be like a right arm posterior. So me standing like this. Again, we have the head of the radius articulating with the ulna proximally. I mentioned earlier this ulnar styloid process. So that's going to be, well, I'll show you that in a second. That's going to be kind of part of your wrist essentially. And the radius has a styloid process as well, called the radial styloid process, as you might guess. Remember, the interosseous membrane is binding those two bones together. And the proximal radial ulnar joint I mentioned is pretty cool because it allows your arm to rotate. And so what happens here, this is a right arm in anatomical position like this. Those bones are parallel. We have the ulna medially and the radius laterally. But when you rotate your arm at the elbow, that joint rotates there, and essentially those bones cross over. So what happens now is at my elbow, the ulna is still medial and the radius is lateral. But now down at my wrist, when I'm like this, they've crossed over and my radius is now medial and the ulna is lateral. So it provides this kind of interesting motion where these two bones essentially cross over each other to allow you to rotate your arm. And if we look at a video, oops, there we go. You can see how the head of the radius just rotates in this ulnar notch. So notice that when you rotate your arm, your ulna is barely moving at all. It's your radius that's doing all the moving, and the ulna more or less stays where it is. And that allows you to turn your hand completely over and at the same time maintain stability at your elbow joint because the ulna is not moving at all relative to the humerus.
Break your arms.
Mhm.
If you were to break your arm, you have to get like metal plate in it. How would that affect that rotation?
Depends where the break is. So if you break your arm like down here or something like that, not really much at all. But if you break the bone near the head or something like that, it would have much more impact on that mobility there, for sure. Go ahead, Zoe. Double jointed at the elbow? I don't know the answer to that. I think it depends on the nature of being double jointed. If it's a matter of, what we call double jointed is often just really, really flexible joints, like really flexible ligaments around those joints. So it just depends on where those ligaments were really flexible and how it allowed extra flexibility at the joint. Yeah. Cool. All right. That's all I want to do today. We covered a lot today. I'm going to just go ahead and skip ahead. We'll talk about the carpals and the pelvic girdle, all this good stuff on Friday. For right now, I just got a couple questions for you on your way out. A couple reminders, actually. Quiz 2 will be Friday. Remember, it's going to be on Blackboard, open book, same format as quiz 1. You'll have through Monday to finish it. And it will cover material. It will start with the integumentary system and cover through the radius and ulna that we covered today. So material we cover in class on Friday will not be on the quiz. I don't like to have you quizzed right after we've covered it because you don't have any time to study it. The quiz is worth 30 class points. Remember that Danny is offering tutoring sessions, tutorials on Thursday. So that's tomorrow from 6 to 7. We'll be in the Ice Cube room at Beagley Library. So keep that in mind. And just as a reminder to see your class program, every class on Friday, I have a course reflection survey, just asking you for some feedback on how the course is going so far, what resources are useful for you, that kind of thing. And that's due before class on Friday, and we're just 2 class points. It'll take you less than 10 minutes. Otherwise, I've got a dumb cartoon and a ticket out for you today. Go ahead, and once you do that, we're good to go. And just let me know what questions you have. Otherwise, I will see you on Friday.